Hey guys, welcome to Need It Make It. I'm Mike. So finally I have the Creality K1 Max, which is the big brother to the Creality K1 that I have. And of course, yes, it is larger, but there are some other features built into this printer that the K1 does not have. So in this video, what I'd like to do is get this thing opened up, take a look to see if there are any lingering issues that have not been resolved with the K1 Max, because there were some little issues with the extruder and the bed level and so on. Then we're going to get this printer printing some big prints. We're going to see how well it prints them, and then we're going to actually test those prints out to see if they actually work for the thing they're supposed to do. So, stick around. So if it wasn't already obvious, we have the Creality K1, which has a 220 by 220 by 250 high build volume. And then Creality K1 Max has 300 by 300 by 300 build volume. So it is considerably larger in all directions. And you can tell that by the size of the box that I had to unpack. It's just massive. Now, there are some downsides to a build volume that is that big, but we'll get into that a little bit later. What I'd like to do first, I'm going to take the side panels off here so we can see inside and have a better look at what's going on. And we can review what the differences are between the printers. Okay, so you can see here we are running the newest of the new extruders for the K1 Max. It's the exact same one on my K1, and this is not the one that came with the K1 printer. This is the newer one. The original one looks like this. Now, there have been several different versions of this. If this is magnetic, the back piece here, then you have a newer version. And this one here has the removable fitting. This version is built in. Now, I believe the K1C has an additional change to the extruder. There's a spring in here on the K1C. As far as I know, the pancake stepper motors are identical between these two printers. They do have the same product code. So, of course, the K1 Max has this scanner, and the K1 does not have that scanner mounted to the side. So the purpose of this is to scan the bed for its unevenness, make sure that it is accounted for perfectly. The other option when you get a scanner like this is that you can calibrate your filament as well with it. And that's pretty important because that's a huge time saver on a printer like this. So for the K1, they have a filament runout sensor on the back of the cabinet. For the K1 Max, it is inside the cabinet. There's a little bit more space, so I guess they were able to include it within. For the K1, we have the little switch in here where you can adjust the voltage. That is not the case at all for the K1 Max. It does not look like there is any place to adjust the voltage, so it must have a different power supply setup. And over here we have an Ethernet port, and this is specific to the K1 Max. The K1 does not have this feature. It's a nice little thing to add if you are concerned with protecting your work, for example, and you want to send to your printer through a wired connection. And here we have the carbon filter. The K1 does not have a carbon filter, but you can add it on as an accessory. Now, one thing about this filter is you can kind of see through it. So I'm not sure exactly how much it's capturing. It probably is better to have it than to not have it at all. Now, this is not just regular carbon. Of course, this is activated carbon, which is supposed to do a better job at catching those volatile organic compounds that could be poisoning you. Better than this, though, is to try and vent your printer outside. Now, one feature I really like is that this K1 Max has a completely flat top, whereas the K1 has this kind of domed top on it. And if you own a K1, you'll know that you have issues with your cable chain kind of bunching up in here, making lots of racket. You shouldn't have the issue here. There's a lot more space inside for the cable chain. And we have a little camera here where you can monitor your prints in the K1 Max. But again, the K1 does not come with the camera, although it does have a wire connection, so you can just add that on if you want to. It looks to me like we have the exact same auxiliary fan for both printers. I'm not going to pretend that I know anything about the electronics that is going on in these printers, but at least you can see that there is a difference between the K1 Max and the K1 as far as the power supply goes. I believe that that might be related to the way that the bed has to be heated on the K1 Max because it is such a big bed. We'll also do a test a little bit later on to see how quickly the K1 Max bed heats up. Well, since this is open, now is a good time to talk about the bed level. It's actually bed level because it's not how level the bed is or how level the printer is, it's how parallel everything is. So that's what we're shooting for here. Now, if you just got a printer, you may not actually know how to even see that. And you can type in your IP address into your search bar. You can find that on the network tab in the printer. And then you'll open up the Creality UI and you should see the mesh and you'll be able to see how far off it is from being parallel. But also you'll be able to see how far off the bed is from being flat as well, which could be important depending on what kind of prints you're making. So first up, let's take a look at how level the bed is. Now, some people have reported that the bed can be out by as much as 2 millimeters from the highest point to the lowest point on this printer. This is a large bed, so I can see that being possible. This is how my mesh looks after the first probing sequence, and it is off by a little bit too much for me to just leave it. I'll show you a quick demo of how to adjust the bed to get as close to parallel as possible in this video, but I also have a very detailed dedicated video to just that subject, and I will link that one up there. So what we have here is one motor driving all of the Z lead screws. There is no easy way to automatically make everything parallel. So for us, we need to make the adjustment here manually. So we've got two screws here. You just need to remove the one towards the front, which locks the position more or less. Okay, so I'm going to take this belt and I'm going to just slowly drive it this way in order to bring the bed down as far as I possibly can the rest of the way. Okay, that's as far as I can bring it. So now we need to remove the belt tension. And you can use a screwdriver, that's what I found works really well, or you can use your strength as well. And then you can bring these down as far as you can just by hand. And each one has a stop at the corner. And I think this is part of the reason why everybody's having so much trouble with this. The location of these stops is not necessarily parallel or at the right height to make it parallel with the frame up at the top. Okay, so that is good for all of them. You can put the belt tension back on. I've closed everything back up, and then we're going to rerun that probing sequence again. And here is the new mesh. It shows a slight improvement compared to the original, but unfortunately it's still not good enough. So what we need to do now is install shims under the lowest areas, the back and the left front side, and we're going to need to raise them up to the same height as the front right. This is going to be necessary if you're looking for precise parts, because if you don't do this, the firmware will compensate for the difference for you over a predetermined distance. And eventually what will happen when it gets to a certain height, it will be able to extrude a layer parallel to the gantry. The problem is that left untouched, the overall part height will not be accurate. And for small parts, it's not really a big deal, but for larger parts, it can be, especially if you're trying to connect parts together. So I think it is just better to make the adjustments, not to mention that seeing red in your mesh just is not a good look. So I've raised the left side up by 0.8 millimeters and I've raised the back by 0.9. And then after rerunning the mesh probing again, I was able to get to this point, which isn't too bad at all. And you can still see that the bed is warped. It's say warped by about 0.5 millimeters or so. So over here on the K1, we have the Bowden tube or the reverse Bowden tube coming out the top. This tube was actually inside of the cable chain originally. And because I was having some issues with the cable chain hitting up against the side here, I decided to put this out the top. Now also, inside the cable chain, it was coming into the extruder in a very tight radius, and I thought it would be better to have this more gradual curve for the feeding of the extruder. So I have these little clips here that I printed and I've got it on top. Now if we take a look over at the Max actually has two wires within the cable chain, and then they have these clips. And I noticed that the cable chain is quite a bit lower, it's longer, and we've got this clip hanging down that rubs on this rail. The other ones probably won't rub, just this one. Build plate is clean, and I've just applied some glue stick for the first print as well. Next, I want to remove any residual grease from these two rods. I'm not worried about the Y travel on both sides. Those are running with linear bearings, so that's okay to run with grease in those. But here we have bronze bushings, and although they are probably lubricated with graphite inside there, I can't actually tell. It's better to have a little bit of light oil rather than a heavy grease that's on here. I wonder whether that grease is just on there for protection. I'm not 100% certain. In any case, I can use my hand of rod, and this end here fits perfectly. So we can just go over that rod like so. Okay, and then I have some light oil. I'll just apply a couple drops of light oil. Next up, we need to activate the ability to do motion advance. So here we have, they call it motion advance. It's actually normally called pressure advance, but we're going to activate that here. First layer detection, print pause doing false. That sounds good as well. I'm not going to turn on AI detection at this point. So after doing this, we should be able to see the option also in Creality Print, and it should do motion advance, pressure advance, so that we can get this filament calibrated automatically. So I mentioned earlier that the bed on the big printer is heated differently than on the smaller printer. So let's go ahead and do a test. I'm going to get this one up to, let's go ahead to 100. Say okay and start. And we'll see how long it takes maybe to get to 60 and then to 100. So that's pretty good. We have a little over 1.5 minutes to get to 60. So I'm going to call this at around 4 minutes. It was able to get to 100. It looks as though it slowed down near the end to try and hit with the 100 right on. So that's fine. If I were to set this to 110. Okay, there we have it. You can see it was able to get up to that number really quickly. Oh, let's go ahead and get our first print started. So as far as how the part turned out, it's pretty good. There's only one issue here we'll talk about in a second. The back of it looks really good, really nice. So this is where the automatic calibration from the so-called LiDAR scanner is supposed to take over. So I can feel a raised area here. So the pressure advance settings that it is trying to adjust for, it's not quite right. And you can see the seam that's placed right here. You see that there's a raised area. That's supposed to be much more flush. Now I actually have to ask, why is the seam here? It should be on the sharpest corner. I'm not sure why Creality Print put the seam here, but I should have noticed that, but that is not really a big problem. Overall print quality is good. Unfortunately, we have a combination of the bed warp and the part itself has slightly warped. You can see here it'll teeter-totter. So I need to play around with the design and see if I can somehow compensate for that, or the bottom of this can be sanded to be flat. I don't know if it was me that made the mistake or if it's something in the software, but this is a fairly large part, and when I had the calibration set up on the side here as well, it looks like there was a bit of a conflict, and unfortunately it printed the brim and then shifted the part over and then printed in a different location, just slightly, maybe by about 10 millimeters or so. But Creality Print does not tell you where the calibration is going to occur, so you can't place your part. You have to kind of assume where it's going to need to be placed. So I should have set it a little bit further over to the right-hand side, and maybe that would have avoided that problem. And you can see on the bottom of the part where the brim came right through. Next up, I want to actually take another look at this LiDAR scanner and how it operates, because it doesn't seem to be completely calibrating the filament properly, even though I can see visually myself which one would have been the correct choice for pressure advance. So let's take a quick look at that, and I'll turn the lights off as well so we can see it a little bit better how it's operating. So this print actually looks really good. So good, in fact, that the only seam that I can see is down here. The other seams, I can't really even tell where they are. Okay, so this print actually turned out pretty well, but something very strange happened with this print. The bed is concave in one direction, really. It's kind of scooped. This print, though, is going the opposite direction. So when I took it off of the build plate, look at this. You can see it's nearly flat. Very close to being flat. We're off by 0.5 millimeter in the opposite direction of the bed. The bed is down by about 0.5 millimeter, and this is up by about 0.5 millimeter. So if you're wondering what on earth this thing is for, this is called a throat plate. And this is the original throat plate that came with the table saw. So here's one from plywood that I made. And it does the job, works pretty well. So here is the plastic version. I guess we need to see if it actually fits. I did do some reinforcement on the back. Let's see if it fits. Not too bad. Now these other holes here are just to add in some set screws so you can raise the level so it's perfect. This is actually pretty good. It's probably usable as it is. Now, because I didn't print this heavy duty, I'm not going to be using this particular one. This is just for a test to see if everything worked out, and I'm pretty happy with that. There's a little bit of roughness up in here as well, and that's probably because of the overhang that I didn't have supported. So here's what my lights normally look like. They've got this pretty terrible plastic shield on there, and there's no light diffusion at all. So with this one, now before I go over all the good, the bad, and the ugly of this printer, make sure that you like and subscribe if you haven't already, and hit that notification bell as well so you always know when a new video is released. So how about the good points first? The print quality is pretty good. Layer alignment seems to be consistent even on large prints and even at higher speeds. Yes, it is bigger, so you can print bigger parts. That's good, but it actually can also be a negative if you're not careful. Prints can be monitored through the app, and that's a nice feature, of course. AI detection for the first layer seems to work, and it will pause the print. The printer is very fast, and the hot end is able to keep up as long as you're not printing with too large of a nozzle or too thick of a layer height. And one of my favorite features, the printer can be rooted. You can gain access to the configuration file, and then you'll be able to get some of the newest features like bed leveling using CAMP installed. This printer also has a nice touchscreen and it's pretty easy to navigate. Overall, I like the look of this printer. It's clean, it's professional, it's easy to clean as well, and it also looks like it has a pretty strong frame. So now some areas of improvement. The LiDAR scanner is not really a LiDAR scanner. It is a laser that is set at an angle, but it doesn't seem to do a perfect job of calibrating the filament. It also doesn't calibrate the flow from what I can tell, which is important if you want precise parts that actually look good. For the best results on this printer, a manual calibration is still going to be required. Now the calibration zone is also very large, and it tends to interfere with the first layer of larger prints. And Creality Print does not designate a zone in the slicer for it, so I end up just running right through it. So if you want a perfect first layer on your prints, it's not really ideal. Now, not to keep on harping on this, but if you're not using LiDAR and you're not scanning the bed height precisely, there isn't really a way to calibrate the filament exactly. The check of the first layer cannot and does not seem to scan the entire surface of the build plate. This printer is supposed to have dual hands-free auto bed leveling, and from what I can tell, it's using pressure sensors for the most part. I've seen no other system that seems to be able to compensate for the unevenness of the bed here. Now, because of this, it's obviously having trouble laying down a perfect first layer. AI scanning during the print, well, that didn't work for this print, and this is something you need to activate under the AI camera settings. I'm not exactly sure how often it's using that. I'd like to see a lighter weight gantry on this printer as well. The larger printer is running the same size steel rods, which are going to have more mass. They're also going to have the ability to flex a little bit more over the larger span. Now the bed is not parallel and it is warped, and if you want precise parts, you're going to at least need to make some adjustments yourself. Now with a bigger printer in general, when it comes to printing large prints that are heavy duty, warpage starts to become a problem. If the parts come near to the edge of the bed, they're going to be able to lift up on the corner of the build plate and it'll end up causing some problems. So printing in a closed chamber is going to help a lot to reduce the shrinkage. And with a bigger part, cooling is less of a problem, so closed is the way to go. Also, the auxiliary fan is pretty small compared to the size of the build plate. I don't really see this being a problem though, because if you're printing small parts at high speed, you just need to keep them towards the center area. If you're printing larger parts, cooling, again, really isn't an issue. So most of my prints worked out. I had one fail, which I attempted to print as nearly a solid part, so that was probably a bit of a setup. Now with a bit of calibration and dialing in, I can always get better results here as well. This is still a capable printer, but it actually can be more capable if you root it, open it up, and you can activate the latest and greatest open source features available through Klipper, like adding more probing points for your mesh or using CAMP, which is an adaptive probing method that I plan to do myself. So here's the deal. It is pretty much a larger version of the K1. There aren't many major changes. The most important point here is that the LiDAR scanner isn't LiDAR. It's a laser set at an angle with a claim of 1 unit of measure in accuracy, which is the approximate size of a bacteria, and that just can't be correct. To accurately calibrate filament, it needs to know the exact bed height, and then it can measure the extrusion that's placed on top of that bed. Yes, there are quite a few things on this printer that could use some improvement, but I still like it actually. I've already been able to print several parts which would have otherwise needed to be broken up into separate pieces. So if you're planning on purchasing this printer or you already have one, I hope this video helped you out. Thank you to all my patrons for helping to support this channel and making videos like this possible. Take care everybody. We will see you on the next one.